Okay, everybody, how we all doing? Getting to the end of the organic unit. We've been talking a lot about carbon chains and branched chain hydrocarbons, and how that you have a longest carbon chain, you have the name, and then you put branches off of it. But we've been talking a lot about is really doing hydrocarbons and hydrocarbon branches. But there is a whole group of other atoms that you can add to these chains. A good analogy is a tree. All trees have trunks and all trees have branches, but it's really the different types of fruit that you can hang off trees, and trees produce these different types of fruits that really characterize, the different function of a tree, or characteristics of a tree is what kind of what fruit it produces. So if you want lemons, you'd grow a lemon tree. If you want oranges, you grow an orange tree, and so on. So what we can do is we can decorate a carbon chain with other atoms. And these other atom groups are called functional groups. Now, the reason they call them functional groups is because they provide a different function or a different um, characteristics and properties when you have these different things. So if you take a look at table um, R, which is our last table on the table, you'll take a look at this and you'll see that this is labeled functional groups. And when we label functional groups, you'll see the word functional group is here. Okay, the class or the name of the functional group is in this column. The functional group of what it actually is in this column. Okay, and you'll see whenever you see these lines or these dashes, that means it's bonded to the carbon chain. All right. The general formula really, these two columns are really the same. The prefix R simply means that's the rest of the chain. Okay, so that would be the rest of the carbon chain. If you see R prime, that simply means that the two chains can be different. They can be the same or they can be different. So R, it can be different than R. And in the last example is really the key to this, is the fact that in the last example here, they not only give you an example, but they also give you the structural formula, okay, and then the name of what that would be. Okay, so it kind of helps you along with the kind of thing. So we're going to go one by one here. I'm going to go through this rather quickly. If you need to back up and go through it again, that's fine. And that's really what we're going to do. There's a lot of them. Again, you're not necessarily that you're going to have to memorize this, but at least it's a way that you can get an idea how things go. So the first thing is something called uh, the halides. Okay, and the halides simply are simply single bonds. Okay, that use halogens on the chain. So the chlorine, the fluorine, the bromine, the iodine. Okay, and you're going to use basically the halogen prefix to tell what you're dealing with. So if you had like a methane, if I can get the color here. All right, if you had in this case you see chloropropane. So if you had three propanes, okay, like that, and then you had a chlor on the second carbon had a chlorine, you would toward two chloro. So you're simply going to use that as a prefix for that kind of thing. All right, so that would take care of the halogens. You're always going to see them in front of the name of the main chain. So propane would be three carbons, a chlorine would be on carbon number two. All right. When we get to the ending of the chain in this case, all right, the end of the chain, for an alcohol, you're going to add OL at the end of the chain. So your OL can be anywhere on the chain. So again, alcohols can be their single bond. They can be anywhere on the chain. So the end of this would be, so if you take a look at the example they give you, they're giving you propane. So here's your three carbons, your propane. Okay, and then you'll see that the OH group is actually on the end of the chain. So we call that one on carbon number one. We call that one propanol. So you can see the end of the name it would be that. All right. Let's see if I can get the pen color to change here to yellow. There we go. All right. So that would be help. So you would have a, three carbons like that, and then you would put an OH group at the end. Remember, the OH group would be your alcohol, and that would be that would be on carbon number one there. All right. Next one down is called an ether. What an ether is simply a carbon branch, uh, a carbon that is chain that's broken by a hydrogen. Oh, sorry, broken by an oxygen atom. So you're going to put an oxygen in between the chain. Now, this is a little different. If you take what they show you here, you'll have a carbon. So if you follow along with the example, um, you'll have a carbon, okay? your carbon will go to another so you'll have a CH3, here's a CH3, okay, and then an oxygen will be bonded to the oxygen, okay, that's bonded to another carbon, all right, that has a CH2 on it, and that's bonded to a CH3. Right? You'll see, so you see right in the middle here, you'll see that this oxygen is bridging the two carbons. Now, the way we name this is that you're going to have a one carbon piece on one side and a two carbon piece on the other side. So this carbon piece, whenever you have a one carbon piece, we call that a methyl, right? A one carbon piece. And on the other side is called an ethyl. That's a two carbon piece. So you have a methyl and an ethyl on either side of an ether. So that's why we'll call this methyl, ethyl, ether. Kind of sounds like a silly name, but that's the way it goes. All right. All right. So moving on. So we've taken care of the halides, the alcohols, the ethers. And now we start with something that could be a little tricky. You just have to make sure you're paying attention to it and focusing. Is that if we're going to start to use a double bonded oxygen. Now, a double bonded oxygen can be if it's on the end of a chain. And the reason the aldehyde, you'll see the aldehyde group is on the end, is because it terminates with a hydrogen. Now, this hydrogen at the end, because hydrogen only forms one bond, you can't continue. So you can't go any further. So this double bonded oxygen is going to have to be at the end. So when we look at something called propanal, okay, what we're going to do is the ending of the al of an aldehyde is going to only occur at the end of a chain, right? And to kind of show you that idea is look at the name propanal. So propanal would have three carbons, 1, 2, and 3. But then we're going to take the double bonded oxygen and we're going to put that at the very end. All right. And you can see if you end it with an H, then we can't continue the chain. So aldehydes have to be at the end. And if they have to be at the end, they'll never have numbers because they always have to be at the end. So if they're always at the end, you don't need the numbers. So this is a three carbon chain, prop, right? AN, again, propane means that you have, that's an R by the way. A propane means that you have single bonds. But then you have this group at the end called aldehyde. So I'm going to put propanal at the end of that. Okay. So again, this gives you an example. So you really can't lose here if you understand how the examples are built. All right. Now, if you take that double bonded oxygen, again, we're going to use it again, and go to the next one, next functional group, we're going to do this called a ketone. And a ketone would, and again, an idea behind alcohols, again, we're going back a little bit, but alcohols, we know what they're used for, right? We can use, they're in beverages. You can also use them for fuels. Glycerol is a good example of alcohol. There are all alcohol groups on all types of things. Sugar molecules have alcohol groups in them. Okay, ethers used to be used for anesthetics a long time ago until they found out they were very, very flammable. Aldehydes have sometimes pleasant smells to them. They can be used in fragrances, and they can also produce in flowers and things like that. All right, so propanal. When we move that move that oxygen to the middle of a chain, you can see there's not hydrogens on both sides. This time it could be carbons on both sides. And you move it to interior carbons, we're going to call it a ketone. Now, a ketone is going to end in ONE, okay, and it's going to be found on interior carbons instead of on the end. Now, the example they give you in the reference table is called pentanone, and you can see pent means 5. So we're going to have 1, 2, 3, 4, 5 carbons. So we draw them 1, 2, 3, 4, and 5. You could see that you cannot put them on the end. If the oxygen was on the end, then that would be an aldehyde. So we're going to have to put the carbons on either one of the interior carbons here. All right. Now there's options, right? So you could put it on carbon number 2, or you could put it on the carbon number 3. So in this case, in this example from the reference table, I'm going to put it on carbon number 2 because that's what it says. It says 2-pentanone. So the 2 is really a direction on where to put the pentanone. So 2-pentanone, okay, means exactly that. It says on carbon number 2, I'm going to put an ONE, which is a ketone, on a 5-carbon chain. All right, so that would be a pentanone. Now, if you put it in the middle carbon, that would be carbon number 3, 1, 2, and 3, and 4, and 5. Okay, if you put it on 4, that's the same thing as carbon number 2. All right, now we've run out of options, right? We can either put oxygen atoms in the middle of the chain, or we can put them on the end of the chain. So that's going to be something you're going to have to worry about. So what we're going to do then is we're going to combine a ketone, all right, with an alcohol. So if we take an alcohol and a ketone paired together, we have something called an organic acid. And again, we've done organic acids too already. Remember, that is our COO, our COOH. Okay, now what we're going to do with organic acids is we're going to take the name of the chain, okay, prop, all right, so propane would be 1, 2, 3 carbons, and we're going to add oic acid to the end of it. Okay, so oic acid, okay, can be anywhere on the chain. However, it's usually going to be at the end. Okay, you could usually at the end of the chain is going to be a straight chain acid, but you could pop them off the middle of the chain if you branch it off. All right, so again, a propanoic acid would be C to C to C to double bonded O to OH, or you could think of this as CH3 CH2. Okay, and you could also have a COO at the end. And again, the COO would be the COOH group. That's this on the end of the chain. All right, so that would be oic acid. All right, for an ester, okay, esters are going to be a subject of a different way that we're going to name. So we're going to hold off on that. So we're going to end in O8. I know that really doesn't make any sense with some of the other ones that we see up here, but we're going to do a special naming rule on that. We're going to see that in a little bit. So you're just going to hold your horses on that one. Okay. Now we kind of run out of options with oxygen, and we move on to nitrogen. And there's some quick nitrogen groups. You've heard of the word amine before, amino acid. You've heard before. Okay, and that typically is a derivative of ammonia. Okay, ammonia would be NH3 if you had it isolated. However, if you take the hydrogens off and you have this as far as carbons, and you mix it with a carbon compound, then you have something called an amine. Okay, and very easily the end of an amine is actually amine, and you're thinking attached to ammonia is what you're thinking here. So in propanamine, prop meaning 3 carbons, 1, 2, 3, and you're simply going to attach the nitrogen to it. So you would have a C, a C, a C, and on carbon number 1, you would simply attach 2 hydrogens and a nitrogen, which would complete the bonding for nitrogen. Again, nitrogen would usually have a lone pair. You would have your hydrogens. So this would be called prop, and propane. Again, there's a propane is right here, and amine. So where is your amine? It's going to be sitting on carbon number 1. So we call that propanamine. Now, if you put the nitrogen in carbon number 2, it would be 2-propanamine, and so on. All right, so again, it's really just reading the reference table on how to read the compounds. Now, if you take a ketone, okay, and you combine it with an amine, you get an amide, okay, and again, you'll end in amide, kind of easy. So if you had propanamide, again, you would have 3 carbons, okay, a double bonded oxygen on that 3rd carbon, okay, and then you would put an amine on it. So an amine and a ketone together produce propanamide. Okay, so really kind of simple way you can do this. So this becomes your functional groups. The next step is just really just practice some of these things. If you have to go back over this and check it, you can. If you combine acids and amines, you get amino acids. So if we go to the next slide, let's just draw a few things. So if we have, in this case, oops, if we go to functional group practice, and now we go to here, we go to ethanol. Let's just say we want to draw ethanol with a prefix eth means 2 carbons. So I'm going to draw 2 carbons. Ethane, the AN here means single bond, so I'm going to do that. And then I have an OL. Well, an OL, okay, OL simply means alcohol. That's an OH group, okay? And since it's a small chain, I'm simply going to put this anywhere. I could have put this on the 1st carbon, that's fine. But if this is on this carbon or that carbon, it's still carbon number 1. I fill that with my hydrogens, okay? And I would have the ethanol would simply be my compound. So this would be the correct compound for ethanol. Okay, now the next one would be pentanoic acid. I see I have oic acid. Oic acid is my COO, okay? And I want to make sure that an oic acid is also a C with a double bonded oxygen and an OH. You'll have to look at your columns on that. I know I have 5 carbons separated by a single bond. So I'm going to take my 5 carbons, 1, 2, 3, 4, and 5. Okay, and I will, on the last carbon, make sure I put my double bonded oxygen and my OH group for my Cu. Fill it with hydrogens. And thank you. Have a nice day. We are done with Mr. Pentanoic acid. So that's done, right? Pretty easy to do. Okay. Now you could have put this on the front carbon also. So you could do it either way. Again, if you did that, you would just be rotating this in space. Okay. Now 3-heptanone. How we draw that? Well, we know we have heptanone. We know our main chain is heptane. Okay. So we'll go ahead and go 1, 2, and 3, and 4, and 5, and 6. 1, 2, 3, 4, 5, 6, and 7. Okay. Now it says heptanone. And one is a carbon with a double bonded oxygen on it that can be bonded on both sides by carbons. However, where do I put this thing, right? Because there's so many options, right? So I can't put it on the end. I could put it on anywhere here, but it's telling me where. It's telling me to put it on carbon number 3. Now, which one's carbon number 3? That's up to you. All right. I usually read from left to right, like most of us do. So make this carbon number 1, carbon number 2, make this carbon number 3. So on carbon number 3, I'm going to put a double bonded oxygen there, and then I'm done. So just go 1, 2, 3, hydrogens, hydrogens, hydrogens. No hydrogens here because you have 4 bonds already. 1, 2, 1, 2, 1, 2. Okay. Bookend carbons have your 3 H3s, and we are golden here. Okay. So that would be that. If you wanted to put the molecular formula for the top one, you can go CH3 CH2OH. That's how you tell it's an alcohol. Okay. Pentanoic acid, we can go CH3 CH2 CH2 CH2. The N carbon will be COOH. Okay. In this one, we can go CH3 CH2 CO. There's a CO. CH2 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 CH3. Okay. Now, if we flip it around the other way, and instead of giving you the name I want you to draw, well, what if I give you, here's the drawing, here's the actual structural formula. How do I go and then deal with the name? Okay. So what I want to do is take my longest carbon chain here. That's my longest carbon chain, right? So I know my longest carbon chain is there. Okay. Now I know I have a little group here that's hanging off the chain, and I know I have something here that's hanging off the chain. I have a carbon that's hanging off the main chain, like at the trunk of the tree, and I have some fruit here. So 2 pieces of fruit, really, 2 pieces of things hanging off. Let's name the chain first. That's always the end part of the name. So that would be 1, 2, 3, 4, 5. So I'm going to use the prefix pent. There is no double bond on the carbons, so I'm going to call that AN, pentane. Okay. Now what I have here is an ending with a double bonded oxygen at the end of the chain. Now because it's at the end of the chain, that's called an aldehyde. So I'm going to end the pentane with pentanal. I'm going to change the name from pentane to pentanal. Okay. I don't have to put a number because aldehydes are always at the end of the chain. Okay. Now, so that takes care of that piece of fruit. We've named that and we know where it is. We do have a 1 carbon piece hanging off the chain on this side of the molecule. Now, because everything's on this side, I'm going to call this carbon number 1, this carbon number 2, 3, 4, and 5. Okay, and because we are hanging off of carbon number 2, and there's a 1 carbon piece which is called a methyl that's hanging off 2, I'm going to put methyl here, methyl pentanal, but I have to tell you where it is, right? Because this could be here and it could be on the other carbons. So I'm going to make this 2-methyl pentanal. Okay, let's do that again. I have on carbon number 2, I have a 1 carbon branch, 1 carbon meaning meth, branch meaning YL or piece, okay? And where is that piece? It's on a 5 carbon chain with an aldehyde at the end. So that's what 2-methyl pentanal means. All right, so just a few examples here. You have plenty of examples in your packet. If you need to go back over this, do that. Okay, and again, if we had to write the condensed structural formula for this, we could do that really quickly. We could say CH3, CH2. Okay, now the 3rd carbon would be CH2. The 4th carbon would be CH. Okay, we're going to have to tell the reader that the CH3 is attached to that. So what we're going to do is we're going to open up parentheses and put that in parentheses to say that that belongs to that. okay? And then we're going to write CHO, okay? And that's the designation here that you have an aldehyde. So that's the condensed structural for example number 4. All right, so that looks pretty good. The only thing we have to worry about in this case next really is this ester thing. So really quickly, esters are a little different. They're a little bit more complicated. So we'll take a look next at looking at our esters. Okay, now esters are interesting compounds. They're synthesized from 2 different organic compounds. And the process is called esterification. We'll get to that a little bit later. But esters are simply organic compounds, okay, that are formed from the reaction of an organic acid. Okay, so you're going to use your so your COOH is here, okay, and alcohols, which is an OH. Okay, now when these ester molecules are formed, okay, water is also going to be produced as a product. Okay, and esters are also going to have pleasant smells, and they're going to be responsible for the flavors, okay, of smells of fruits and vegetables. And ester is going to be made in the lab for use in artificial flavorings. Okay, so that's kind of what esters do. Okay, now how you form an ester is very simple. All right, quick pause. Okay, sorry about that. So organic acids, okay, what they're going to do is they're going to react with the alcohol. Okay, an organic acid, sorry, is going to react with an alcohol and then produce the ester plus the water. Now you don't have to know the exact mechanism for this and how this works, but I'm just going to show you really quickly. So I'm going to choose two. I'm going to choose an acid, and I'm going to choose propanolic acid. Let's review that really quickly. Prop, okay, is going to have 3 carbons, okay, and then it's going to have your COOH at the end. All right. So you'll have CH3, CH2, okay, and the COOH at the end, okay? And then I'm going to choose methanol. Methanol will have a CH3OH, okay? So it would have 1 carbon, meth, and an OH group at the end, okay? So what's going to happen with this is when these get together and you add them and you mix them, what's going to happen is the H, okay, from the alcohol and the OH, okay, from the acid, okay, is actually going to be sucked out. So they're going to be pulled out this, okay, and that's going to form good old-fashioned H2O. So that forms the water molecule, all right? So I want you to visualize this now. So this is going to go away. Think about that being erased. So that's going to go away now. So if I can go here, if I go there and let's just do this way. Okay, let's just say I get rid of this now. I get rid of my water. Okay, now this oxygen has nothing to bond to, and this carbon has nothing to bond to. So what's going to happen is this oxygen is going to go and bond to that carbon. Okay, and what we're simply going to get is a new compound. So we're going to actually link the two together, and when we link the two together, you're going to get this option. Okay, you're going to get this. You're going to get C, 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 double bonded O. Okay, so notice that's the piece to the left. And you're going to bond that to the oxygen and then the other side. So you're going to link the two together. Okay, and you're going to have this new compound. So notice you simply took the left side molecule and the right side molecule and you join them, and in the middle you get this like new thing that you formed. Okay, that is the ester, or this whole molecule is the ester, but this is really the new thing that you made. Okay, so if you look at table R, you'll see an ester really. What an ester really is, it's a carbon double bonded to an oxygen that's single bonded to an oxygen, but it's in the middle of a chain. All right, so this piece in the middle of a chain is called an ester group. All right, and it comes from the acid and the alcohol of your choosing. Now, it depends. Now, it doesn't really matter which acid and alcohol you choose from any length of the chain. So if you look at this, there's really 3 pieces. Okay, the piece that came from the acid Okay, that's the acid part of the ester. Okay, and the alcohol part of the ester. Now you have to remove the water. Okay, so there's three parts to the name of this, and it's actually kind of easy. You just have to get the rhythm. All right. So what we're going to do is, how would you actually name this? Well, what you're going to do is you're going to take the right side of the ester, the alcohol part on the right, and you're going to name that first. Okay. One carbon piece meth, that becomes methyl. Okay. And the left side piece, the main chain, is prop. So we're going to use prop for that, propane. Okay. And the middle part, this central part here with the oxygens, we're going to call that O8. Okay. So it's methyl propane O8, okay, which references the three parts of the ester molecule, or you can think about it as three parts. It's really one big molecule, but it has different regions to it if you want to think about it that way. I know it's a little crazy. You have to get used to the thing. So I think of the right side having the YL, the left side that's attached to the double bonded oxygen is the chain that has the O8 part. Okay, it's just the way it is. It just takes practice. Okay, now this would have a certain flavor or smell to it that would be, that would describe or be representative of that particular fruit or flower. All right. So in that case, you would have methylpropanoate. All right. Now to practice this a little bit, okay, and again, this is just an interesting little slide. I mean, you don't have this in your notes, but you'll see it in class maybe. Is that if you take a look at all of the alcohols at the top and all of the carboxylic acids or the organic acids from the side, and you mix them with your four carbons and you get your different carbon chains, you could actually get all of these different smells of fruits and flowers and vegetables and plants and things like that. And it's interesting how many you can make. So you can actually synthesize these artificially in the lab, and you can get some really cool things out of it. So if you wanted to pause it here and just take a look, you can get ideas about this. Okay, so really quickly, let's just play around with some esters. I'll go pretty quick. You can always go around. Okay, so let's say you had to draw the following esters. Well, you're starting with pentyl ethanoate. Okay, so again, the O8 part is the double bonded oxygen part. So, and that's attached to two carbons. So I'm going to start on the left side with 1, 2, eth, right? I'll have my ethanoate on that side. So there's my ethanoate. Okay, ethane is my O8, and then my pentyl again is that right side. So pentyl means 5, so I'll have 1, 2, 3, 4, and 5. Okay, and this of course would be hydrogens. I'm not going to draw them right now for speed. Okay, but that would be the pentyl piece on that side, and the ethanoate part is here. Okay, so that would be that, and that would smell like bananas if you're interested. Okay, and the next one would be ethanoate again. So I would have 1, 2 carbons for eth. I would have my O8 attached to my eth. Okay, there's my O8 part. Okay, there's my eth part there. Okay, and then my octyl. Octo means 8. I have 8 carbons. 1, 2, 3, 4, 5, 6, 7, and 8. A huge molecule. 1, 2, 3. Okay, we got to put our things down here. Just make sure I got this right. 1, 2, 3, 4, 5, 6, 7, and 8 looks pretty good. So that would be octyl. Here's your octyl part. And there's the ethane part and the O8. Okay? And that would smell like oranges. My favorite fruit. Okay? Butanoate, it's a little different. Butane means 4 carbons with the O8. So I go 1 and 2 and 3 and 4 this time with my O8. There's my O8 group. Again, the O8 is that attached. There's my but is there. And I have pentyl, 5. 1, 2, 3, 4, and 5. Okay, so that's the way it goes. If you wanted to see the structural for this, I know I'm jumping around, but if you wanted to see the condensed, we can go CH3. Okay, in the middle here, it's a little strange. Watch me. Well, actually, I made a little mistake here. There's no H there. Okay, so I would go C O O. So C to C O O. Here's a C double O, and then it's easy. Just write on out. CH2, 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 CH2. So CH2, CH2, CH2. There's 4 CH2s. Yeah, 1, 2, 3, 4, and then your CH3 at the end. So you could do that with these two as well. Now let's flip it around. I'm drawing my esters here. What if I have to name them? Again, name them. Name the right side first. So here's my YL piece. Okay, so I have ethyl, right? And then I have a 3-carbon piece here, propane, okay, O8. Again, the O8 is my oxygen part, 3 pieces, ethyl, propane, O8. Okay, this one, on the right side, you have a 1-carbon piece, methyl. Okay, there's your 1-carbon piece there. Here's my chain. What's my chain? 1, 2, 3, 4, butane. Okay, and I have my O8 piece. So here's my butane. Here's my O8. Okay, methyl, butane, O8. Not so bad, right? Now on the right side, you have 4 carbons. So butyl, right? The YL. Here's your butyl part. Here you have the same 4 carbons, butane. You can repeat. And here's your 2 O8. Right? So butyl butanoate, methyl butanoate, ethyl propanoate, pentyl ethanoate. Notice that we're changing the carbon chain. You change the carbon chain on each side, and you got it. You have a different smell and on what you have. Right? So that ends the show. I hope you're able to follow along. If you need to go back over this, definitely rewind it and check it out. Just understand functional groups are simply groups of atoms that you can place on the carbon chain that give you different characteristics. And there's so much to know about them. This is just a quick little burst of what to do and how to name them. Again, bring your questions to class. Have a great day.